Welcome everyone. I want to talk a few things about a few things, I should say. The test for this 1D motion Thursday. There were 2 quizzes that you were supposed to have taken on Friday, Monday. One of them was a concept test or portion review. Formative, I don't remember exactly what it was called. 1D motion formative review, something along those lines. As of Sunday at about 9:30, I removed the quiz and I reloaded it again immediately. But what I did is I went through and I wrote question by question feedback on it. So instead of just getting the question right or wrong, it's like, why is this the right answer? I felt like I should have done that ahead of time, but I didn't. So if you took the quiz prior to Sunday at about 9:30 probably, there was no question feedback. You are more than welcome to take that quiz as many times as you want. I would encourage you, if you did take it before that, to maybe go and take that opportunity to read that feedback, just so you can kind of see why those answers are the way they are. There was also a Canvas quiz that you were supposed to go through, and it was a calculation portion. So take care of that if you haven't done that. I want to talk about a few of those things from the formative portion of the concept portion of that Socrative quiz, because there's 2 parts of your test on Thursday. There's a concept portion, a multiple choice question portion that kind of walks you through the big ideas of 1D motion, and then there's another part, the calculations that we've been doing a lot of. And a lot of people struggle with the concept portion, and they say, hey, we never talk about this, but those ideas are what you do to build your equations. It's your if-thens, like, hey, what is your max height, or what's the acceleration at max height? It's those things that you're using on all those calculations. So I want to talk about a few kind of takeaways from these. Vector versus scalar quantity. Remember, Despicable Me, vector is committing crime with both direction and magnitude. So vectors has 2 components. They have a number and a direction associated with it. If it's a scalar quantity, it's simply a number. It's simply a number. It's how big. So time is scalar, speed is scalar, distance is scalar. But vector quantities like velocity, acceleration, displacement, those are, I think I said those are vectors. That's why we put positives and negatives next to those things. Okay, and that tells me the direction. So make sure you know the difference between scalar and vector and what is what. So is time scalar or vector? Well, it's a scalar quantity. Well, but acceleration, acceleration of gravity is negative 9.8. Negative is a direction, therefore that must be a vector quantity. Speed is a scalar quantity, but velocity is a vector quantity. So distance versus displacement. The question we asked ourselves a long time ago was, for distance, is how far do you travel, versus displacement is how far am I from my starting location. So in this example, if we went 4 meters and then we went another 4 meters, the distance traveled would be 8 meters. I walked 8 meters. Okay. However, my displacement in this case is also 8 meters. But displacement is how far am I from my starting location. So I'm 8 meters, 4 and 4 is 8, but direction is a positive direction because it is moving to the right. Okay, so my distance and displacement could be the same magnitude, have the same number associated with it. When we talk about distance and displacement, they don't always have to be the same. For example, if I walk 5 meters to the right and I walk 3 meters back to the left, the distance I traveled is 8 meters. However, my displacement, how far did I go? I went 8 meters. My displacement, how far am I from my starting location, is I'm 2 meters in the positive direction to the right of where I started. My displacement is less than my distance. The term we sometimes use is as a crow flies. So if you go to your friend's house, that's going to be a distance traveled. Your car, whatever your car reads. The crow would fly straight to your friend's house without using roads. It could be the same, but the crow could be less. The crow is never going to fly further than you will in your car, assuming the crow flies in a straight line. And that's what that's saying. So your distance could be the same as your displacement, or your distance could be greater than your displacement, but your displacement will never be larger than your distance. The follow-up question was talking about speed versus velocity. Well, speed is distance divided by time, and velocity is displacement divided by time. Scalar quantity, vector quantity. So if speed is distance divided by time, 8, let's just say this is 10 seconds, we could say 8 divided by 10 would give me my speed. In this situation, my velocity is also 8 divided by 10. It would have the same magnitude, the same number associated with it. My speed and velocity in this example are the same because my distance and displacement are the same. However, in this situation where we went forward 5 and back 3, my distance is greater than my displacement. So because it's 8 divided by 10 compared to 2 divided by 10, my speed will be larger than my displacement, and it can never, my speed will be greater than my velocity because my distance is bigger than my displacement. Okay, so that's kind of one of those other kind of pieces. There were 2 questions about graphs, and they were really just slopes. What does the slope of a position versus time graph give you? Velocity, just something you gotta memorize. What does the slope of a velocity versus time graph give you? Acceleration, just something you gotta memorize. I guess you could go through and you could derive it and you say, well, change in position or change in displacement, rise over run, distance divided by time. Hey, that's velocity, you could. Or you could say, well, change in velocity divided by time, that sounds like an acceleration. Absolutely, you could. Or you just memorize that those are what they are. Then there were a series of questions that talked about are things speeding up or slowing down. That was not necessarily off of the graphs. Okay, in graphs we asked those questions. But I stood in front of the class with my fingers pointing like, hey, if this is this way and this is it, that's exactly what this is. So when we talk about, like, does an object speed up or slow down, we're talking about velocity and acceleration. Okay, so I have a velocity finger and I have an acceleration finger. And my velocity finger is pointing this way, which means I'm moving in this direction, and I'm accelerating in this direction. What happens to my overall speed? If I speed up or slow down, if I'm moving this way and I accelerate this way. Speed up, you're right. I think that was you on the video, good job on there. Okay, you're gonna speed up. Okay, you're gonna speed up. If I'm going this way and I accelerate this way, I'm gonna go faster. Same thing if I go this way. And my finger's pointing in the negative direction, and my acceleration is pointing in the negative direction. It's the exact same idea. I'm gonna speed up. I'm just gonna speed up in the negative direction. Same idea here. When I drop this ball, the velocity is down. Acceleration due to gravity is down. What happens to the speed of my ball? It speeds up, it goes faster. If I throw this ball up, however, now on the way up, my velocity is up. My acceleration is down. And what happens to the ball on the way up? It slows down until it stops. If I'm driving this way, but I'm accelerating this way, stepping on the brake, I'm slowing down. So my fingers point in the same direction, speed up, opposite direction, slow down. Speed up, slow down. Speed up, slow down. Okay, doesn't matter how we do that. So some of those questions we're talking about positive velocities and positive acceleration. Positive just tells me direction. If it were to say if I was accelerating to the right and my velocity was to the right, same idea. My fingers are pointing this way, or negative and negative. Okay, there was a series of questions like that. Then there was quite the series of questions that was talking about acceleration due to gravity. The questions were very specifically worded the way they were to try to make some points and reinforce some ideas. So in those question feedbacks that if you go back and take, you're gonna see there's a lot of the copied and pasted, the exact same reason for each one because it's the same problem type. But they kind of progressed slightly. They were the same question with slight differences. So the first question was something along like if I were to drop a tennis ball versus a bowling ball. Now we're doing this oversimplification of in the absence of air resistance. Okay, so in the absence of air resistance, what object or what force is acting on a tennis ball? Gravity and gravity alone. If I take a bowling ball and I drop it in the absence of air resistance, only give me gravity, they're both free fall problems. Galileo said that in the absence of air resistance, that all objects will accelerate at the same rate. Okay, so the question about the bowling ball and tennis ball was to try to illustrate the point that all objects, regardless of the mass of that object, are going to accelerate down on Earth at negative 9.8 meters per second squared. So any object moving freely through the air, free fall, The acceleration due to gravity is down on Earth at negative 9.8 meters per second squared. Then it was shifted to another series of questions. And the next series of questions was talking about dropping a ball, and it was talking about dropping at the beach in Florida. Why the beach in Florida? Because that's sea level. Okay, if you're on the beach, that's literally sea level, right? The waves are hitting you in the feet. So if you're at sea level, and you drop the ball, the acceleration is gonna be what? Well, it's gonna be down at negative 9.8 meters per second squared. Absolutely, you're right. Now, what if you go to the top of Mount Everest? Now, the idea is when I go up in elevation, I'm physically further away from the center of the Earth. So one would think, well, that should probably have some impact on it, right? Because astronauts are floating up in space and they're weightless because they're really far away. And that's a false statement, by the way. They are not actually weightless. They have apparent weightlessness, and it's not because of the way how far away they are. It really has to do with the fact that they're in a free fall. Conversation for another day. But if we were going to, and this is just a very crude scale, when we talk about the acceleration due to gravity, it does have an effect based upon elevation, but it's from the center of the Earth to the surface of the Earth. So if this is from the center of the Earth to like the beach in Florida on our globe, right? So if this is the center of the globe and this is Florida, if I go to the top of Mount Everest, one of the highest elevations in the world, and you say one of, I thought it was the highest. It depends on how you measure highest mountain in the world. There's 3 different ways. That's another conversation for another day. So this is Florida. Like Mount Everest might be like right there. Okay, so we might be beach in Florida versus Mount Everest. Okay, did my finger move? Absolutely, but it's percentage, like actual change-wise, not very much. It has a slight impact. You and I would not be able to measure the differences. Therefore, we say all locations on Earth, despite elevation, are going to have the same acceleration due to gravity of down at negative 9.8 meters per second squared. So no matter what the mass is, it's down at negative 9.8 meters per second squared. No matter the location on Earth, it's down at negative 9.8 meters per second. And the last point I tried to make is about the direction of the object. So if I were to take this ball and I were to drop it, you'd say, hey, the ball is accelerating down because of gravity, therefore the acceleration down is negative 9.8 meters per second squared. You people on the video might want to hit the gear and go like 0.7 speed because I'm talking really fast right now. I don't know why. You guys just got to deal with it. So drop the ball, the acceleration due to gravity is down at negative 9.8 meters per second squared. You'd all say, yeah, it's a free fall problem. According to that sheet, down at negative 9.8 meters per second squared. Absolutely, you're right. If I were to toss this ball in the air, on the way up, you would say, hey, gravity's pulling that ball down. Absolutely, you're right. And you'd say, well, because that's the only force acting on that ball, you're absolutely right. It must be a free fall problem. You are still absolutely right. Therefore, the acceleration is down at negative 9.8 meters per second squared. We're all okay on that, and this is the weird one. At max height, velocity is all right, sorry. Take a deep breath. This is for you. At max height, how fast is that ball going? What's the velocity right there? Zero, right. Okay, so at max height, you should just know that it's on your equation, if-then sheet, problem type. At max height, the velocity is zero. True statement. That's a fact you should know. At max height, the velocity is zero. But what force is still acting on that ball? Gravity. Therefore, the acceleration, it's the only force, therefore it's a free fall problem, which means, according to this sheet, that the acceleration due to gravity is negative 9.8 meters per second. So the point that those series of questions we're trying to make, and I'm trying to reiterate for you right here, anytime an object is moving freely through the air, no matter the mass, no matter the location, no matter the direction that the object is moving, if it's moving freely through the air, in the absence of gravity, the only force acting on is gravity, and the acceleration of that object is going to be down at negative 9.8 meters per second squared. Okay? Now, expect to see some questions on the concept portion of your test about that. Okay. Enough of that. This sheet is on that back table. If you didn't grab one, you're going to want to grab one in a little bit. It's Progress Quiz 2.7, I guess I'm calling it. There are 6 questions. I would strongly encourage you to go through and try it and then check it against the posted answers. These are problems similar to the problems that you will see on the calculation portion of the test. I do apologize. You are going to find that in a lot of these questions, you end up using the same equation, one equation more frequently than the other. That just happened to be how I wrote it. It's not an indication that you should always use that equation. It just happened to work with the information that I wrote in those problems. So just so you're clear, that's not necessarily an indicator that you should always use equation number 3. When I went through and I made the key, I highlighted the answers, okay? But then I also tried to highlight certain things. So the fact that number 1 says a car starts from rest, I highlighted is a good indicator that my initial velocity was 0, or is an indicator, because the second one says constant velocity. Well, constant velocity means my acceleration is 0. So I try to connect kind of those pieces, the words from the problems to identify problem types, which then we can get information from your yellow sheet. There's an answer key posted here, there's an answer key posted there, there's an answer key posted back there, right next to the stack where you picked them up. There is also an answer key posted on today's agenda. Right below the video linked here. So you have some time today, we have a chunk of time. It's really just an opportunity for you to go through and get those final questions answered. Maybe you have some worksheets, homework sheets that you haven't finished yet. Now would be a great opportunity to ask me some of those questions. Go through and work through some of these and say, hey, I don't understand this type of problem. Okay, what kind of problem type is it? What do you mean with problem type? Hey, let's pull out the sheet. Is this true? Okay, then we know that. Is this true? No? Okay, then forget that. What about this one? Oh, yeah, then it's that. Okay, that's the idea of this problem sheet. You also have a couple labs you should probably be turning in if you haven't done so already. But that's really kind of it. So you have some work time. Please ask questions, please ask questions, please ask questions. Your test is going to be on Thursday. If you have a calculator, please bring your calculator, real calculator.